So for this experiment, we're going to be working with a crystal violet dye. This experiment has two parts to it. The first part is generating a calibration curve. In order to do that, we're going to make solutions with the crystal violet at different concentrations. We're going to measure their absorbance and create a graph of absorbance versus concentration. Then we're going to use that graph to determine the concentration of an unknown solution of crystal violet. In the second part of the experiment, we're going to react the crystal violet with sodium hydroxide. And then instead of measuring absorbance versus concentration, we're going to be measuring absorbance versus time. So as the crystal violet reacts with the sodium hydroxide, it goes from having a color to generating a colorless product. So we'll see the absorbance decrease over time. And then we're going to use that data to figure out if the crystal violet in that reaction is zero order, first order, or second order. So to start with the calibration curve, making the various solutions, I'm going to be using a 25 micromolar concentration of crystal violet. This is my stock solution. And then I'm going to be generating 5 different solutions of crystal violet by diluting them with water. Now, in order to make the different solutions, I don't want to measure volume with a graduated cylinder. It's not going to be precise enough. Instead, I'm going to be using a serological pipette. So this is different than our pasture pipettes that we've used in other labs. These are graduated. There's markings on it like a graduated cylinder, but they're marked more precisely. So what I'm going to do to use this is I'm going to take a piece of cotton and put it at the top here. And then I'm going to take my bulb here. Now, the point of the cotton is actually just to protect the bulb. If you accidentally draw up too much liquid, we don't want that liquid to get inside the bulb because we can't clean inside here. So that's the point of the cotton. With these bulbs, the first thing I'm going to do is I'm going to squeeze at the top and just depress the bulb like so. And then I'm going to place that on. Now, there are 2 other places on this red bulb here. One is marked with an S and one is marked with an E. When I want to draw liquid up into the pipette, I'm going to hit the S. I'm going to squeeze it from both sides. And then I'm going to move that into the test tube. And so when I want the liquid to come back out, I'm going to squeeze the E to empty the liquid back out. So you can see I have my test tubes here. They're marked A through E. And so for test tube A, I need to measure 1 milliliter of my stock solution. So I'm going to draw up extra just so you can see what happens here. So as I squeeze, you can see liquid is being drawn up. And you can see that the liquid stays put. It's not until I hit the E that the liquid then is emptied out of the pipette. All right, so I need 1 milliliter, and I do want to be precise about this. Okay, I have my 1 milliliter, bring that over to A, and empty that out. I'm going to do the same thing for B, C, D, and E. In each case, I'll be adding an extra milliliter. So in test tube B, there's going to be 2 milliliters of the stock solution, then 3, 4, and ultimately then 5 milliliters of the stock solution. So I'm going to do that now. Now what I need to do is I need to add deionized water to each of these test tubes so that each test tube has a total of 10 milliliters of solution. So I'm going to do the exact same thing. I have another pipette here that I'm going to use. Again, just place a piece of cotton here, put my bulb on. Now, in test tube A, I need to add 9 milliliters of deionized water, whereas in test tube E, I only need to add 5 milliliters of the deionized water. So I'm going to do that. So now I have my 5 different solutions. I do want to mix them to ensure that the crystal violet and the water, that we have a homogeneous mixture. So the best way to mix a test tube is to hold it at the top and just kind of flick it at the bottom just to make sure that you have even mixing. So I'm just going to kind of do that with each of these. You can see that they get darker as we go from A through E, which makes sense. E has the most of the crystal violet solution, whereas A is the most dilute. So I should expect solution E to have the highest absorbance because it's the most colored, whereas solution A, I would expect that to have the lowest absorbance because it is the least colored and it has the lower concentration. Now what I need to do is I need to set up my spectrophotometer. We're using the SpectroViz from Vernier. And I'm going to be using the program Logger Pro on my computer so that I can measure the absorbance of these different solutions. So this plugs in via a USB port into my laptop. The first thing that I'm going to do is I need to calibrate this with a blank. So what I mean by that is I have a cuvette here that is just filled with water, with DI water. And the reason for that is I need to zero out any absorbance that might happen due to the water. These are aqueous solutions, so they have water in them. Because I want to measure the absorbance of just the crystal violet. So I'm going to have a blank here so that I can, it's just like zeroing out the balance so that I can calibrate my spectrophotometer to make sure that any absorbance due to water is zeroed or canceled out. Now, if you notice the way I'm holding a cuvette, there's, because my fingerprints, any oil or anything on my fingers, that would also affect the absorbance. So I'm actually holding it by its edges. And then the other thing is that I'm going to use a Kim wipe. So a Kim wipe, it's softer than a paper towel. So I don't want to scratch the cuvette because that would also affect my absorbance. But I also don't want to use a tissue, which would leave a residue on the outside of the cuvette. So that's the point of the Kim wipe here, where I'm going to just wipe down the sides of the cuvette just to make sure that there's no fingerprints, there's no particles on here that could potentially affect my absorbance data. And then I just place that in here. And so now what we're going to do is I'm going to show you how to use the Logger Pro software. So, just gonna move that out of the way there. So the first thing that I want to do is I want to go up here to experiment. And there's an option to calibrate. I'm going to calibrate the spectrophotometer. Now, you can see here that the lamp inside the spectrophotometer, it does need to warm up, but I've already had mine plugged in. So my lamp is already warm. So I'm going to skip the warm up and I've placed my blank inside. So now I want to click Finish Calibration. Okay, and then I simply hit OK. And now my spectrophotometer has been zeroed out. Now the next thing that I need to do is I need to take my stock solution and figure out what's the best wavelength to determine the absorbance. So you can see that I have all of the wavelengths in the visible range. I'm going from 400 all the way out to about 800 nanometers. So I want to figure out an absorbance for crystal violet that's not too low and not too high. Ultimately, I'm trying to find an absorbance where, I'm trying to find a wavelength where the absorbance is going to read at about 1. So I have another cuvette here, and this is filled with my stock solution. So I'm going to place that inside the spectrophotometer, and I'm just going to hit the collect button. Once the graph appears, I can hit stop. And what this is telling me is that I get a maximum absorbance here of around 600 nanometers wavelength. But again, I want to pick a wavelength where my absorbance is closer to 1. So I'm probably going to be picking something in the 550 range. So in order to set up my calibration curve, I'm going to go to this button here that says Configure Spectrophotometer. And I'm going to click that. Right now, I have my graph set to absorbance versus wavelength. I'm going to pick the third option here where it says absorbance versus concentration. So I'm going to select that. And you can see that by default, it will pick the wavelength where the absorbance was the highest, but that's not where I want to pick. I want a wavelength that's closer to where the absorbance was 1. So that's 531.0 nanometers. So I would record that value in my lab notebook, and then I'm going to hit OK, hit yes. And now what I have is the basis for my calibration curve. I have absorbance on the y-axis, and I have concentration on the x-axis here. So what I'm going to do now is I am going to fill up cuvettes with solutions A through E. I'm then going to measure their absorbance and enter their concentration. And then that's how I'm going to be able to generate my calibration curve. So I'm going to go ahead now and fill up cuvettes with my different solutions. So now that I have my calibration curve set up here, my absorbance versus concentration, I need to collect the data. So I still have the stock solution in the spectrophotometer. So that's the first one that I'm going to collect. So I'm going to hit this collect button. And you can see this blue triangle has appeared. And then I'm going to hit the keep button, and I need to tell it the concentration. Now, our concentrations we've made our solutions in micromolar. I am going to need to convert that into regular molarity, moles per liter. So when I enter this in, it will be as molar and not micromolar. So then I hit OK. Now, I'm not going to hit the stop button. All I'm going to do is take the cuvette out of the spectrophotometer and replace it with the different solutions A through E. So I'm going to start with solution A. Just give the cuvette, just wipe it down. Then I'm going to hit the keep button again. Now solution A was 2.5 micromolar, because remember, we added only 1 milliliter of stock solution and 9 milliliters of water. So this is even more dilute. I'm going to hit OK here. Then I'm going to do the same thing with B, C, D, and E. Just wipe this down. Now, one of the things that I want to look at before I hit stop is I want to look over here at this absorbance versus concentration data, because this is going to give me an indication of how good is my data even before I generate a calibration curve. We know that absorbance and concentration are going to be directly proportional. So if I double the concentration, my absorbance should double. So if I'm looking here at my data and I'm looking at the data point here, it's 3, where it was 5 micromolar versus 5 at 5 here, where it was 10 micromolar. My absorbance should be double 3 compared to 5. Now it's not quite, right? Because solution 3 is 0.196, whereas here for 5, it's 0.369. It should be a little bit higher, 0.4, if it's gonna be double. So it definitely increased, but we might see some issues with our calibration curve. We can do the same thing, you know, looking at this one 2 versus 3 here. Again, we see that this is a little high or this is a little low. It's a little hard to tell, but something's definitely off because my concentration doubled, but my absorbance more than doubled. These are the things that we want to look at when we're in the lab while we're doing the experiment, so that we know, hey, I might need to remake some of these solutions. They might not be perfect. That's not something that we want to figure out the night before the lab is due when we're trying to write up the experiment. So this is something we want to look at now. Does my data make sense? Now, in order to generate the calibration curve, I'm now going to hit stop. And you can see here, it's mostly linear, but that solution at 5 micromolar does look a little high. Now, I can go up here to add a linear fit line, and it's pretty good. The issue is the solution B, something is a little bit off there. It's a little more concentrated than it should be, but overall, A, C, D, E, and my stop solution, they look pretty good. So this is a pretty good calibration curve. Now, the last thing that we need to do is we need to measure the absorbance of an unknown solution of crystal violet. Because that's the point of the calibration curve, is to use this curve to figure out what is the concentration of this unknown solution. So I'm going to fill up a cuvette with the unknown crystal violet solution, and I'm going to put that in the spectrophotometer. And if you look over here in the bottom left-hand corner, this is telling me what the absorbance is. Now, I'm not going to graph this because I can't graph this data point because I don't know what the concentration is. But I'm going to use this absorbance, this 0.238, essentially. And then I'm going to use the equation from the line to figure out, all right, well, 0.238, where does that hit the line? And ultimately, what is the concentration of the unknown solution? So it's going to be somewhere around here, somewhere between the 5 micromolar and the 10 micromolar. So I'm going to need to record this number in my lab notebook. And then I'm going to use the equation that I'm getting from the calibration curve to determine what the concentration is of the unknown crystal violet solution.